Ubiquitin is a small 8.5 Da regulatory protein that has been found in almost all tissues ubiquitously of eukaryotic organisms. It was discovered in 1975 in Israel by Gideon Goldstein and further characterized throughout the 1970s and 1980s. There are 4 genes in the human genome that produce ubiquitin: UB, UC, UBA52 and RPS27A. The addition of ubiquitin to a substrate protein is called ubiquitination or ubiquitination. Ubiquitination can affect proteins in many ways. It can signal for their degradation via the proteasome, alter their cellular location, affect their activity, and promote or prevent protein interactions. Ubiquitination is carried out in 3 main steps: activation, conjugation, and ligation, performed by ubiquitin-activating enzymes E1S, ubiquitin-conjugating enzymes E2S, and ubiquitin ligases E3S, respectively. The result of this sequential cascade binds ubiquitin to lysine residues on the protein substrate via an isopeptide bond, cysteine residues through a thioester bond, serine and threonine residues through an ester bond, or the amino group of the protein's N-terminus via a peptide bond. The protein modifications can be either a single ubiquitin protein (monoubiquitination) or a chain of ubiquitin (polyubiquitination). The ubiquitination bonds are always formed with one of the 7 lysine residues as well as the very N-terminal methionine from the ubiquitin molecule. These linking residues are represented by a K or M, which is the 1-letter amino acid notation of lysine and methionine, respectively, and a number, referring to its position in the ubiquitin molecule. First, a ubiquitin molecule is bonded by its C-terminus to a specific lysine residue on the target protein. Polyubiquitination occurs when the C-terminus of another ubiquitin will be linked to one of the 7 lysine residues or the first methionine on the previously added ubiquitin molecule itself, for example on K48, K29 or M1, forming a chain. This process repeats several times, leading to the addition of several ubiquitins. Only polyubiquitination on defined lysins, mostly on K48 and K29, is related to degradation by the proteasome, referred to as the molecular kiss of death, while other polyubiquitinations, for example on K63, K11, K6 and M1, and monoubiquitinations may regulate processes such as endocytic trafficking, inflammation, translation and DNA repair. The discovery that ubiquitin chains target proteins to the proteasome, which degrades and recycles proteins, was honored with the Nobel Prize in Chemistry in 2004.